Good morning, good afternoon, good evening, everyone, wherever you are. My name is Bas, and I'm a product manager here at GitHub, and I look after the CodeQL analysis engine that powers GitHub's code scanning functionality. And for those of you who haven't heard about code scanning yet, not to worry, I'll go through all of that today. It does exactly what it says on the tin. It scans your code. It scans the code that developers write and flags up security vulnerabilities in that code. And this new feature is currently in public beta. So that means that anyone can sign up. And I'll tell you a bit more about that later. So today I would like to show you that code scanning functionality. I will actually go a little bit under the hood and show you how the internals of it work. And I would then like to show you how there's an entire community of security researchers who are here to help you to secure your code. If you've tuned into this channel before, then you'll know that this will all be in the form of a live demo. And I'll be hopping between github.com on my browser. I'll be doing some coding, live coding and Visual Studio Code. And I'll probably do some bits and bobs in my terminal as well. And if you've done this sort of a live demo before, then you probably know that there will almost certainly be something that goes wrong at some point. I've literally roasted some coffee beans earlier today as an offer to the demo gods. So let's hope that it will all be good today. One of the other things that we always have to worry about slightly when we demo our new security functionality is that we might actually end up revealing a vulnerability that wasn't known yet. So in other words, if I'm not careful, then I might end up dropping a 0-day here on Twitch, which is typically frowned upon in the community. So if you were here hoping for me to do that, then I will hopefully have to disappoint you, and I won't be doing that today. Luckily, I'm not here on my own. My colleagues Xavier and Aditya are hanging out in the Twitch chat, and I have AJ and Elsalin providing technical and moral support in the background as well. I'll keep an eye on the chat as well myself, so if you have any questions, just pop them in there and I'll try and answer them directly. So for the purpose of this demo, we'll step into the shoes of an engineer who is writing a new Java application. And let me now share my screen. There we go. You should be able to see my screen now. I have started to write a Java application. It's a simple hello world. And I've got a GitHub repository set up, as you can see. And I'm now really ready to continue developing from here. In fact, I've already got some code on a feature branch that should be visible as well here. And I've also got that very same code in my VS Code right over here. The thing I'm trying to make this code do is really quite simple. I'm trying to read a zip file right over here. And I would like to extract the contents of that zip file. And I'm doing that by iterating over every single entry in that zip file. Now, if you're not particularly familiar with Java or with reading zip files, don't worry. I won't go into that too deeply. What I'm doing then in that loop for every single entry in the zip file, I'll get the file name for the file in the zip file. I prefer my file names lowercase just to make the demo a little bit more interesting. And now I've got to do something with the data for that file. I need to write it to disk. So far, so good. I am well aware that my Java skills are rusty at this point. So you know what I thought is I'll just set up code scanning. And code scanning will at least flag up any potential security vulnerabilities that I'm about to introduce. So let me also just clarify at this point that code scanning is really about scanning your own code, because I get frequent questions about this. It's about scanning your own code, the code that you write yourself as a developer. There are other GitHub features that will scan your dependencies, the libraries that you depend on. But code scanning is really here for scanning your own code. So code scanning is in public beta, like I mentioned, and I've signed up for it, so that means I can enable it for all of my public repositories by going to the security tab, and I see the code scanning option right here. When I click on that, it suggests multiple engines that we can use for the code scanning functionality. And today, when anyone can really develop their own engine for their favorite tool, but today I will of course show you our own sort of the engine that GitHub have built in-house, which is called the CodeQL analysis engine. Now, everything in code scanning, all of these scanning jobs are run in GitHub Actions, the GitHub CI/CD system, and that is configured as code. It's all configured as code. So if I click set up this workflow, that means I'm going to set up the workflow for my GitHub action for scanning my code with CodeQL, and it presents me with a template for this workflow. And I'll quite just quickly talk you through a few bits and bobs here. One of at the top of this, you see when the code scanning CodeQL action actually gets run, and it's run on any push to my my default branch, which is called main, and it's also run whenever there's a pull request against that branch by default. It also suggests that I schedule it in the form of a sort of a cron style job. Now, if you're like me, then you always forget exactly how the cron syntax works, but there's a nice handy mouse over there. So this is going to run every Tuesday, 5 o'clock in the morning at UTC. Further down, it configures exactly how this job is run. It has a few bits and bobs that you can configure here, but the default template actually works for almost every case. Also in my case, because I set up my project to use a standard build system for Java, in this case Ant. It has detected that I'm using Java, so we're all good to go. I can save this file to my repository, commit this file to my repository right here, and it goes straight to the main branch. There we go. Now, you'll remember that I actually configured the workflow to trigger whenever there's a push to main. So if everything is working as expected, we should now see on the Actions tab that there is one workflow running. That means that the CodeQR analysis has indeed been kicked off by simply pushing this configuration. Once the analysis is done, it will report any vulnerabilities to me. Now, this is only a hello world program, so hopefully I haven't done anything wrong quite yet. I'll now take a few moments to sort of, let me have a look, actually, yes. So the analysis will now just take a few moments to actually prepare the environment, set things up for us. And in the meantime, why don't we actually create a pull request for the new functionality that I'm about to introduce. I'll just create a draft pull request because I'm still working on this. So this is all in draft. And there we go. Now, again, if everything's working as we set it up, everything's working correctly, then in a few moments, this will automatically kick off yet another analysis. It's now analyzing my pull request already. So while we're waiting for that to happen, let's go back to our editor and actually write the code that we were still needing to write. So let me just zoom in a bit so it's a little bit clearer for everyone to see how bad my Java skills are. We were left over here. There was a to-do, and I needed to do something with, I believe, a file output stream. And I always forget exactly how those work, but file output stream, it's a new file output stream. So I'm going to write to that file, and the file name is the lowercase one that I chose. Now I'm going to do something with a buffer. Get back to that later, but I need to make sure that this thing is closed at the end of it. There we go. Okay. So that's all done. You know what? Why don't I just commit this straight away? So that's safe, and push that off. There we go. Now, if we go to the pull request view, this should now show up right over here. And in a moment, indeed, another check is kicked off. So that means that in the background, code scanning through the CodeQL engine is now already analyzing my latest addition to this pull request. This is probably also a good moment for me to step back and actually have a look under the hood. What is actually happening in the background? What is CodeQL doing? How does CodeQL work? CodeQL is a semantic analysis engine. It's very much like a database engine. It's very much like MySQL or Postgres. It's specifically designed, though, for storing and querying properties of source code. So that means that when we create such a database, or to create such a database, we extract the useful bits and bobs from the source code and store that into that purpose-built relational database. For compiled languages like Java and C and C++, the extraction process happens by very carefully monitoring the build process. So the CodeQL engine is monitoring the build process to see exactly which files need to be extracted. For interpreted languages like JavaScript and Python, the extraction happens by simply extracting all of the information from the files in a particular source root. Once the extraction is complete, then we have a proper CodeQL database. As of today, we support C and C++, C#, Java, JavaScript, Go, Python, and TypeScript. We're planning to release Ruby support for CodeQL next year. So this is all happening in the background, in the cloud, run on GitHub Actions as we speak. But actually, all of that tooling that's running in the background is also available for us to download. So we can actually run these analyses locally in our machine. We can actually create a database in our machine. So I just quickly show you how that works. I have CodeQL, the command line tools already installed. You can just download them from github.com, and I can just do CodeQL database create. I specify that my language is Java, so CodeQL knows what to do, and I'll just store that in a database called my CodeQL database. So you can actually see it's doing some compilation, and it's monitoring the compilation, and it then creates that database for me and stores it. And it is indeed now on my disk. Okay, so we have a database. What do we do with a database? Well, what you always do with a database is to actually fire queries at it. You try and find out more about the data that you've stored. You try and find out more about the code that, that is in that database. And we have a special language for querying this database. You can, of course, write that language in VS Code. I've actually already downloaded the CodeQL extension for VS Code. You can find it on the VS Code marketplace. So let me just open a new VS Code window and open the workspace that I have prepared. And I can start writing a query. Let me first tell CodeQL where the database is. Oh, that's already done. Fantastic. Now I can write my CodeQL query to actually find out what's in the database. Let's check whether the database is sane first. So first we say, okay, import Java. So I want to use the CodeQL Java libraries. Then I want to just check whether there's anything in this database. So I'm going to check which files are in the database from all of the files in this database, and we'll call these things F. I want to check, let's say, all the files that have more than 10 lines of code, and I would like to know more about that file. Actually, I would also like to know how many lines of code there are and where that file lives. Okay. So now one of the downsides of doing a Twitch stream like this is that to some extent it actually feels like I'm talking a little bit into a void, and I can't see the expression in people's faces. But if I have to guess, then some of you are staring at your screen and thinking, hold on, this looks a bit like SQL. And the order of the query is all wrong. And there's dots in it, and it looks a bit object-oriented. What's going on here? And you're absolutely right. CodeQL, the query language, is indeed, it has some similarities to SQL. It is object-oriented. And that means that we can very easily abstract away some things. We can depend on libraries to implement things for us. So for example, I don't really know or mind how this get number of lines of code is implemented. That's all done by the library for us. Another very important key element to the CodeQL language is that it's recursive. I won't go into that much today, but that's very important for analyzing source code. So, okay, we've got a little bit of information out of, we can get a little bit of information about running this query on our database. There we go. That query is now run. Let me try and put that into a slightly more helpful place. There we go. So I have one result. That turns out there's one file in my database of more than 10 lines of code. It has 22 lines of code, and it's located in my application.java. That is the file that we just wrote. Fantastic. So my database contains some data. That's always good to know. Now let's have a next query. We've successfully established the contents of the database. So there we go. Let's actually find out about the method calls in our application. So from, say, all of the method accesses, so that basically method calls, I want to select where things are called. I want to know what is being called, where the thing is defined. For example, which class it is defined. And I would like to find out what the function name was of what was called. There we go. That should do the trick. Okay, I can run that query. There we go. and there are now 5 results. That makes absolute sense. So on line 11 of my application, I call a print line, which is defined in print stream, and a few other bits and bobs. So I can actually click on these results as well. I can just jump to the code, and here we see that the database contains, the CodeQL database contains the source code that we originally wrote, but it's a read-only database, so I can't actually change it. You can see it at the top of the screen here that it's read-only. So we know where the method calls are. Now let's actually try, let's try the opposite actually. Let's find methods that don't have any calls. So let's find methods that are not being called at all. So I want to find from the set of methods, call them M, where I'm going to just count the number of references for every one of these. And I want to just find all of the methods that have 0 references, and then select the method and where it was declared. Okay, we can run this query. Oof, over 8,500 results. Well, there's not that many method calls in my application, surely. But hold on, what we see here is actually that CodeQL has included actual Java standard library things in a database. And that makes sense because sometimes you want to query those as well. So I can quickly adjust my query to say I want to have only methods that are actually defined in my source code. I run that. There we go. So now I have 2 methods that are not called in my application. That's quite special, but indeed, I forgot to actually call the extract zip method from my main method. So that's potentially a bug. So these are some examples of simple query cases, simple use cases for CodeQL. CodeQL is capable of much more advanced analysis. And one of the most powerful features that CodeQL has is what we call interprocedural taint tracking. That means that CodeQL can track data or can recognize data that is potentially under the control of an untrusted user. And we call that tainted data. And then CodeQL can track that data through your application, through method calls, through data structures, into where it's potentially used in a place that can be dangerous. So for example, if you have untrusted user data that flows back and is printed back to a web page, that could be cross-site scripting. Or if you have a user entering their password and you accidentally log that to a plain text file, that's also a good example of where you would use taint tracking or data flow. And we have many of these queries that do this type of analysis. And all of these queries are actually open source. Let me actually show you where they are. Of course, they live on GitHub, and here they all are for all different languages. And you've probably sort of guessed what's happening in the background, what's happening in actions when the CodeQL analysis runs. The code scanning CodeQL action builds the database and then runs a large number of standard queries against your database. And any results are then flagged up as alerts. So let's go back to our pull request on my repository and see how that's going, what the analysis has done. Ooh, some of the checks were unsuccessful, and it has indeed flagged up an error. Let's look at the details. Here we see the output of the actions job, and it suggests that I might have introduced a security vulnerability. I can look at the details, and here we see the details of that vulnerability. it's a very simple example of how taint tracking was used to recognize that the file name inside of, or the file name of files inside a zip file are actually untrusted. You never quite know what people send you. And that file name might well contain ... /... And if you carelessly then extract the contents of that file into your file system, you might end up extracting data to a place that you weren't expecting, and you might be overwriting all sorts of important files in your file system. So this category of vulnerability is called path traversal vulnerability. It's a path traversal vulnerability, and it was first described back in the early 2000s. But it got a bit more attention. It got back into the spotlight in the summer of 2018 when a security company called Snyk, you might have heard of them, organized a campaign around this vulnerability, or a particular subset of this vulnerability, about zip files. And as you've probably guessed, they called this type of vulnerability zip slip. Now, CodeQL runs this query, just like many other queries, and finds these vulnerabilities before those pull requests are merged. Now, you might wonder who actually writes these analyses, who writes these queries. Of course, my colleagues and security experts at GitHub write a lot of these queries, but we're not the only ones who do that. There's a very quickly growing community of security researchers who are helping us secure the world's code by taking their security knowledge and turning that knowledge into CodeQL queries. And because all of those queries are open source, they contribute them back to us. And guess what? This particular query, this very zip slip query that found my vulnerability, was actually contributed by a member of the CodeQL security researcher community. It was back in 2018, just as that vulnerability, as Snyk was releasing that vulnerability, and it was contributed by Dennis Levin. Dennis's pull request was merged after a couple of days. There was a bit of code review, and as soon as it was merged, it was then deployed, and it was then immediately used to scan hundreds of thousands of open source projects. And that's not the only example of an external contributor that we have. Over the last 12 months, we've had hundreds of pull requests of external contributors, of security professionals who contribute back CodeQL queries. Some of them work for large application security teams at companies like Microsoft and Google and Uber. Others are independent security researchers who just have some fun with CodeQL and like to share back. An example of one of them is Artem Smotrakov, I hope I've pronounced their name correctly, who's recently contributed back some very important queries that find injection attacks, for example, against the Spring expression language. And another contributor who definitely deserves a mention here is Jonathan Lateshoe, who's been doing some absolutely fantastic work on finding code that might be vulnerable by HTTP man-in-the-middle attacks, and code that uses unsafe random number generators. And these two contributors are actively participating in the CodeQL bug bounty program. That is run by the GitHub Security Lab. Now, the CodeQL bug bounty program is not your average bug bounty program. We're not inviting you to find vulnerabilities in CodeQL. Well, if you do, then please tell us. But this is a bounty program specifically for finding vulnerabilities using CodeQL. And the bounty that's up for offer goes up to $3,000 US, so it's definitely worth contributing to that. And when you think about it, we really do need all the help we can get, because the number of developers in the world vastly outnumbers the number of AppSec team members and security professionals. So to keep all of that code secure, we better work together. And with the tight integration into GitHub, CodeQL and the CodeQR community help developers do that in two ways. Primarily, of course, by keeping everyone's own code safe. The code that I just wrote and that introduced or almost introduced a vulnerability. But as the open source community is adopting CodeQR themselves, all of the open source libraries that we've come to depend on become safer, and thereby our own applications become safer. So as you might have guessed by now, I'm a great fan of CodeQL. Not only do I think it's a great piece of technology, the thing that really makes me excited about this is the quickly growing community of security professionals who are working with us to help secure the world's code. And there's really no other security tool or place where that happens. So if you would like to join the CodeQR community, then there are many different learning resources available. You can find these at the Security Lab website. That is the securitylab.github.com. And there's a web page that explains exactly what you can do to subscribe to the work that we do, to how you can learn CodeQL through the learning resources that we have. We also have slightly more advanced learning resources in the shape of a capture the flag competition. There is a very friendly Security Lab Slack instance where the security community come together and help each other write new and exciting CodeQL queries. So there is a lot to be found out there. So do have a look at the Security Lab website, and I look forward to, of course, reviewing the PRs that you will contribute back to the CodeQR repository. If writing your own security analyses with CodeQL is not quite your cup of tea, then you might still want to enable the code scanning beta on your repositories, so that you can benefit from all these analyses on your repositories. So it's currently in public beta. If you sign up, you'll probably get access within a couple of hours, if not a couple of days. You can get started with CodeQL from there. I've heard just a ping that we've had a question in the chat from Jonathan. I think probably the very same Jonathan I just mentioned. Hey Jonathan, good to see you again. The question is it eventually the plan for this CodeQL scanning action to be automatically applied to open source repositories by default? That's an excellent question. At the moment, we're not quite planning for that, but we will definitely encourage open source projects more and more to automatically enable code scanning when they create their repository. So we won't impose this on existing open source projects. After all, not everyone is interested in this, but we will definitely make it very clear that this functionality is available for all of open source out there. On that note, I'd like to thank you all for tuning in today and for the questions in the chat. If there are any more questions, I would very happily hang around for a little bit longer, either on camera or on chat, to answer any more questions. I'll just try and find the window that actually has them in it. So if you have any more questions about code scanning, about CodeQL, about the analysis, then fire them at us. You can also find us, of course, in that Slack instance that I linked to, that I mentioned earlier, in the Security Lab website. And I think Aditya has just asked for a last round of questions. I'll hang around in the chat for a bit longer. Thanks all for coming. Thank you everyone who made this possible today. And I hope to see you around in the CodeQL community. Goodbye.